Okay, so in this video we're going to talk about streams, and we're going to be talking about redirecting standard output, standard error, as well as doing pipelining. Now, the first thing you need to do is understand streams. So I've created this awesome little ASCII graphic here for you. So when you run a program, standard input goes into the program, and the program will stream out standard output or standard error, depending on whether it's an error or just normal output. And usually standard output and standard error just goes to a computer monitor, but we can redirect that output using the redirect operator and the file descriptors. So standard in is file descriptor 0. Okay, file descriptor 0. Standard out is file descriptor 1. And standard error is file descriptor 2. Now, I know that's not going to mean much to you now, but we also have these operators. So standard in is less than, standard out is greater than, and so is standard error, but you need to use a file descriptor for standard error, which I'll show you in just a moment. In fact, we'll show you now. So I'll go into a command line terminal, and okay, so over here you can see that we're using sudo terminal 0. I'm going to open up another terminal window, and you can see that it is sudo terminal 1. Okay, so what I'm going to do is I'm going to do an ls command, but instead of just having the normal running it normally, I'm going to use the redirect operator, and I'm going to redirect it to dev pts 1. And you can see here that nothing has happened. But if I click over here, you can see that the ls command output has come to this screen. So I've redirected it into here, and everything on Linux is a file. So obviously this is a special type of file, which is just outputs to the screen of this window. So that's an example of redirecting output to another terminal window. Now, that in itself, may not seem very handy, but what we can also do is we could redirect the ls command to say f, and if we cat f, you can see that our directory listing is in there. So I'll press Ctrl L to clear the screen, and I'm just going to rmf. So remove the file, and what we're actually doing when we're doing this ls is we're actually doing 1f, like that. Because if you omit the file descriptor, then it's just assumed standard output. And if we do that, we get the same thing, cat f. So I'll remove f again. Now, what we can also do is we can redirect standard error. So let's say our entire just tape archive, which will be explained more in a later video. Whoops. So when I create a file, verbo. Alright, so now you can see that we have permission denied error messages because we don't have permission to read some of these files, to be able to save it into the etc tar file. Now, what we could do is use file descriptor 2 for standard error, use the redirect operator, and we could redirect it to ERR, for example. So now when we run the command, you see that there's no error messages appearing here at all. But if we cat ERR, we can see that we have all of those error messages. So we've redirected the errors into a file, which can be handy if you want to keep a track of error messages. You could go through it later. Now what we could also do is, if we wanted to, we could redirect the standard input to a file called out. So now when we run this command, nothing comes to screen at all. But if we cat out, you can see our standard output has gone to the out file, and the standard error has gone to the error file. So basically what it's done is here, we're saying file descriptor 1, which is standard output. We want to redirect it with the redirection operator to the file just called out. And we want to redirect standard error, which is so that's the file descriptor for standard error. That's the redirect operator to ERR. Now, normally you would do it like this. I did a bit of a typo. So normally you do it at the end of the line like that. Okay, so hopefully that's not too confusing. What you can also do is, let's rm out and err, so those files no longer exist. Now if I run this command again, instead of sending it to error, what we can do is we can send it to dev/null. And if we do an ls, you can see that there's an out file, but there's no ERR file. We've got the etc, we've got error.txt, which was from another thing that I've done. But do rmasters.txt. Okay, so now when we do ls, so if I run this command again, you can see that we've got the out file, but we've got no error files. And dev/null is a special place where if you don't care about it, you just want to dump it, get rid of it, you send it to dev/null. In some scripting situations, if you've got like a cron job that runs a job automatically at a certain time, you might not care about standard output. You might send standard output to dev/null, and you might send standard error to a log file. So hopefully I've done enough examples there for you to understand it. Now I know it can be a little bit confusing if you haven't used it before. Actually, before we get out of here, what I want to do is show you appending data. So let's say we cat the bash history file. Let's pipe it. I'll show you piping in a sec to grep. And we want to filter on IP. And we want to send the output to the G file. Now you notice there's no G file exists here at the moment, but if we do an ls, we can see that G now exists. And if we cat G, you can see the commands that I've just run with IP in it from the bash history. Now, if I run this command again, and we cat G, you can see that it's got it in there twice. So it's appended the data to the existing file, where if you do just one, it overrides it. Now, technically this command is 1. So because we omitted the file descriptor, it assumes that it's standard output. So the file descriptor 1, and then the operator is a redirect operator that will append instead of overriding. So now let's go back to our slide, and I will show you piping. Okay, so pipelining. So what we just did in that other command, in fact, let's copy that. We'll paste it in there like so. We'll put a $sign there to indicate a shell. Alright. So what we've done is we're running one command, cat. So that's the program there. And the standard output from that program is going to the pipe, which is that little bar. And then that pipe basically makes the standard output from this program go to the standard input of the program after the pipe, which in this case is grep. So then grep, which is a filtering tool, filters the words IP, and we're using a redirect operator to send it to a file G. And you could make it like that. So because we omit the 1, it assumes 1. But we're redirecting it to the file descriptor 1, which goes to G. So that's how pipe works, and you can use as many pipes as you want. So if we wanted to, we could pipe that information to TAC. Now if we cat G, actually let's just do it with 1. So now we're overriding the file. So now if we have a look, it's in reverse order. So what we've done is we've done cat-n, which does this is the file with file numbers of the bash history. Then we're filtering on IP with grep. Then we're sending it to TAC, and TAC basically lists the file in reverse order. So instead of it being 33, 110, 114, 115, 177, it's doing it in reverse order. So if I show you the command, whoops. So that's the command normally without TAC. And that's the command. So now if we cat it with TAC, sorry. So you can see that without piping it to TAC, this is the output that we get. And then if we pipe it to TAC, we can see that it's in reverse order. So basically what we've done here is you can see that the output of this cat is being, with the pipe, being made the standard input of the grep command, filtering IP, which then goes into the pipe, which takes the standard output from the grep command, puts it into the standard input of TAC, and then what we're doing is we're redirecting the standard output. So instead of sending it to the screen, we're sending it to the G command, to the G file. Now, what we could also do is pipe it to, say, the T program, and you can see that it's gone to the screen. Actually, I should remove G first. So G no longer exists. We'll ls it just to show you. G no longer exists, but if I run this command again, you can see that the output comes to the screen, but we also have a G file. So what the T command does is you can kind of think of it as how am I going to do this? Let's see if we got gedit. Gedit will do nicely. So the T command, you can kind of think of it, whoops, as like a T piece. So let's say you have like a T piece, so you basically get, doesn't look like, but let's say you have input coming down, and it hits this T command, and what it'll do is it'll send it to standard out, and it will send it to a file that you create. So the so here you can see, so it comes in to T, goes to standard output and to standard file. So basically what this, so when the information comes into T through this pipe, it's sending the standard output of TAC to standard output and to G. Okay, so this is pipelining. You can see there's quite a few commands that have gone across there. This video is probably getting a little bit long, so hopefully you understand it. I know it will take time for you to get used to it by actually using it, but it is very, very powerful when you learn it.